Hi everybody, my name is James. Welcome to King's Fine Woodworking. So today is the day we're going to complete the build. I know it's been a journey getting here, but I really didn't want to leave out any steps since it's a very long and involved project. I wanted to be able to show you every step of the way how to do the things that I've done. If this is a project you think you'd like to do on your own, I do have plans available on my website. This table that I've built is a 4-foot by 8-foot table. I also have plans for a 3.5 by 7-foot and a 3-foot by 6-foot available, so there should be size options to fit just about any shop. And there's a link to those plans in the description below, as well as all of the materials that I used to build this project. We're going to start off today by building a vise. I have chosen an end vise because I want a fairly wide one, but I am going to install it on the side of the table. And I'm going to use 2 different woods for the jaws. I'm going to use this Paduke, it's 8/4 for the rear jaw, and I'm going to use Purple Heart for the front jaw. Both of these boards came in very flat and didn't need any surface planing, so I just jointed one edge flat, and now I'm going to rip the opposite edge parallel. The Purple Heart was wider than what I needed for the jaws, so I'm going to turn the rest of it into handles for our Thor's Hammer woodworking mallet. Finally, I'm going to cross-cut them to the exact length that I'm looking for. When cross-cutting on a chop saw, if you take a moment to score the top first before you cut all the way through, you will typically prevent tear out on the top. The next part, we had to flip the whole table upside down. Luckily, I had the strength of 20 men and it was effortless. To start with, we'll need to pull the vise apart, and I'll need to get the bracket that has to bolt into the top. The area where it's going here is the area where I notched out the top of the cabinet so that this will actually mount directly onto the torsion box top from the bottom. I don't know if you could notice there, but the Purple Heart actually extends a little bit below the bottom of the torsion box top. That's optional. I just did that, but I did have to trim that part flush so that it didn't interfere with mounting this piece. After marking the locations for the bolts that go on the top, I'll need to mark the locations for holes for the rear jaw where the bars go through to mount to the front jaw. Then I'm going to clamp the front and rear jaws together so that when I drill those holes, I can drill them all the way through and the 2 jaws will stay in perfect alignment. I'm going to take it over to my drill press and then use a Forstner bit, which is just a little bit bigger than the diameter of the bars. This is important so that there isn't any binding when the bars move back and forth through this jaw. I decided to do a little bit of a decorative end cut on the front ends of the front jaw. Not sure if you can see what I got going on here, but I am using a couple of squares which I have clamped to the board, and those squares are riding on top of my fence, which is keeping my jaw, the board there, vertical to the fence. I'm also going to take a chamfer bit in my router and knock all of the corners off. Now it's time to go ahead and mount everything back into the top of the torsion box. I'm using a shelf pin drill bit here, which is allowing me to put a hole centered in the hole here for pre-drilling to put the bolts in. And I'm using some 3/8 inch by 5 inch lag screws to hold the whole thing together. And if you put a little bit of paste wax on them, then they'll go through relatively easy without getting stuck in there and binding up and creating a lot of friction and making it very difficult to drive. So if you remember, underneath this portion of the table, I have solid blocking going the whole way. So these lag bolts are hitting solid wood the entire way down. Go to that side. Go to that side. Take your body that side. You guys want to put these tools away? Hand me that thing right there. Now it's time to line the jaws up and put the bars through them. And we'll square everything up and I'll bolt the front bracket in. Since the rear jaw is stationary, I can just go ahead and pre-drill and screw that in place. It's important to countersink the screw heads so they're not sticking out. And the small holes that are left won't really be a bump or a problem because we're going to line the face of this with leather. We made sure that the orange wood there, the Paduke, which is the stationary jaw, was perfectly in alignment with the top of the torsion box. And so now we want to hold the purple heart perfectly square and flush with that all the way around, which is why we're clamping it in. This way, when the jaws open and close, they will stay in perfect alignment with one another. These nuts will bolt the bars to this bracket, and then we're going to drill this bracket into the purple heart, which is the dynamic jaw, the one that's going to move in and out. And that's how the system works. The final part, which you can't really see on video, is the nut that is on the threaded rod, which is right behind the two jaws. This scene is kind of a flash forward to show you what this vise looks like once it's all put together. This is after we have just put the leather in, and we're clamping it down to hold the leather after the glue up. We're kind of wiping off the extra glue here, and we'll still need to trim that leather down to be perfectly flush everywhere once it dries. We did use hide glue to bond the leather to the wood, but I didn't really show it on video because it's really just cutting the leather into a rectangle and gluing it on. Our vise did come with a plain wood handle, but my daughter Maya is going to turn one for us out of Paduke. Something like this can really add a nice personalized touch to your bench vise. It certainly isn't necessary, and it certainly is not necessary to use exotic wood for the jaws of the vise. Maple would work just fine for that as well. Here she is marking to put some tenons on each end because she's going to cut some little purple heart end caps for the handle. For the end cap, she's taken a piece of purple heart that was left over from the vise body and cutting it first into an octagon. After that, and a quick trip to the chop saw for length, she's going to put a hole in the end so that it will fit over the tenons on the Paduke handle. It's always a good idea to use a vise for your drill press, especially if you're dealing with small pieces. And finally, with the pieces friction fit together, she's going to go ahead and lacquer this so it will be ready to install once it's dry. For the next step, we're going to build some electrical boxes so that we can have some plug-ins for electricity on our bench. We are using the leftover 1/2-inch Baltic birch plywood that came from our drawers. Anytime I build a project, I always cut the longest or biggest pieces first and the smallest pieces after that, because the smallest pieces usually always come out of the offcuts from the big ones. And that's enough parts for 4 boxes. I'm going to install 1 set of outlets at each of the 4 corners, so no matter where we are around our assembly table, we always have plug-in access. Usually there's 3 or 4 of us at a time working on the table, so it's convenient to have multiple plugs there. And the assembly for this is pretty straightforward. We're just going to glue it together. I'm going to get it lined up perfectly by hand, and then we're going to put some pin nails in it. The pin nails are more or less just going to hold it in place until the glue dries. I always try to take my time and make sure that the edges are lined up exactly perfect. This is the easiest way to get perfectly square structures. And now that we're nearing the end of this whole production, I do want to take one more minute and just say thank you again to all of our Patreon subscribers. Without you, this build would not be possible. And if you guys are interested in Patreon or helping to support this channel, there's a link to our Patreon channel in the description. And I'd also like to say thank you to everybody who takes the time to buy the things that they need from our links in the description below from Amazon. Those are Amazon affiliate links, and each time somebody buys something through that link, if it's a product that you already need anyhow, it actually gives our channel credit, and that helps us to continue funding the channel. And thank you to everybody who watches. Everybody makes a big difference, and we really appreciate it. We love what we do, and can't say thank you enough. So that's it. Pretty straightforward, just a simple square box, and that holds one of these electrical outlet boxes. We'll screw that in, put the outlets in there, and screw a faceplate on, and it keeps the electrical stuff perfectly protected. Now we're going to add some T-track to this tabletop. This T-track is going to greatly enhance the functionality of this as a work table and an assembly table both. This will allow me to clamp things to the surface from any point pretty much on the table. I've clamped down my 8-foot level, which has a perfectly straight edge on one side, and I'm just going to kind of use that as a guide for my router. I'm using a plunge router here. I'm just going to plunge in maybe a quarter or a third of the way deep that I need to go to put this channel in, and hold it against my my straight edge there, and then cut all the way across. I have a 3/4 inch spiral upcut bit in here, which is a high-speed steel bit, and it's very dull. You can see the fibers are kind of tearing out and shredding there, and I probably should have retired this bit a while ago. It's pretty old, and it's cost more to sharpen than I think the thing is worth. So pretty soon here we're going to have to switch to one of my straight cutting bits, and for this purpose actually a straight cutting bit works a little bit better. So I'm stopping on each side about 1 inch from the edge. I don't really see any need to go all the way off the edge with this. I'll likely not be putting a clamp right at the very edge. And if I do, I'll just clamp something to the outside of the table from the bottom to the top. Right about here, I think is when my bit decided no more. So it's time to switch bits. So this is the straight cutter. This is a great bit. It's a new bit, and it cuts perfectly. There's not going to be any tear out, and I probably should have started with this. It's just I kind of like to get as much life out of my router bits as I can. And you probably can notice the bearing that's on the top there. So yes, this can be used as a straight cutter like I'm doing it, or if I want to stick it all the way through, I can use this as a pattern cutting router bit as well. And I often do both. Sometimes I'll get a bit with a bearing on the top and use it for both purposes. And we're cutting the other side of the table here, so we're just about done. It's just basically 4 grooves, and I either did 2 to 3 passes per groove to make the cuts go easy. And so now we're going to go ahead and install the channel. The first thing I'm going to do is install this T-Track intersection kit. The intersection kit allows me to make nice, perfect, smooth transitions from one channel to the other and basically across this intersection. So they're a little bit costly, but they do make things very handy. I need to pre-drill these holes, and I want to use this Vix bit, V-I-X, Vix bit. It's a self-centering drill bit. It's got a little conical shape at the top, which grips the outside of the aluminum at the top, and then puts a hole right in the dead center. That way, when I put my screw in, my screw stays perfectly centered in the hole. It's also a great bit to use for hinges or drawer slides, so they're very handy. I use them all the time in my shop. And one tip when you're putting this T-Track in, these screws will strip very easily, so I recommend putting them in by hand unless you're really familiar and really comfortable with your impact driver or your drill, because it just takes a small tweak to go a little bit too far and strip it. Then I want to do a quick check with the T-nut, make sure it goes through smoothly. Now I will just proceed down the line and put in the T-Track as we go. When we get to the end, it's probably not going to take a full length of T-Track, and you're going to have to cut it to fit, and that's no problem. The aluminum is actually pretty soft, and it cuts without any difficulty on your chop saw. The trick is just to cut a little bit slow, and it won't damage your blade or anything like that. Now the edges of it are usually quite sharp, and so I'll just use a little file and hit all of the edges, even the edges that are going to be buried down into the groove that I won't ever touch. I like to just hit all the edges now so there's nothing sharp if I'm grabbing it or handling it up until the time that I put it in, or maybe if I have to take it out for any reason, I don't have to worry about any sharp edges. When I get to the very end, I have a very short piece here, and it's a good idea to have at least 2 screws in each piece, so I'm going to have to put a hole. So I'm going to use a drill bit that's about the same size as the countersink that's already in there, and this will be my countersink portion of the hole. And after cleaning that up, I will use a smaller drill bit to actually put the hole all the way through. And hopefully you noticed I'm using my awesome new vise. Now to mount this last piece into the table here, if you notice I left some space at the end, so I didn't take the T-Track all the way to the end. This is so I can lower the T-bolt into that portion and be able to slide it in and out of the track, basically to get it off of the table when it's not in use. Okay, so now I am going to put in the bench dog holes. I'll kind of give you an overview of what I've done here. I have created a little jig. I have a 1/2 inch piece of plywood which I traced around it, and I cut it out to perfectly fit the base of my router. And then I set it in place with the router in it so that it was flush to my tabletop, and I used hot melt glue all the way around to affix my router base to this piece of plywood, to my template. I have a board clamped down parallel with the edge of my table, sort of to give me a guide so that I can slide my jig down in order to put the next bench dog hole in. And the bench dog holes, the first series of them here, are going into the dynamic portion, or the moving portion, of the jaws on my vise. This will allow me to clamp a board between the jaws of the vise and the tabletop by having a bench dog in each location. And I also have a 3/4 inch straight cutter in here in order to make these holes. These straight cutters really make nice clean holes. And now you can see the outermost row of holes that are in the moving portion, the moving jaw of the vise. So now I'm going to move my jig back to the very first hole, and I have my jig built in such a way I'm going to line it up with that first hole and then move it forward onto the table. I'm going to space it by 4 inches. I have 4 inches between holes, and I've put a bench dog into the first hole to kind of act as a guide or a template to get me to stop in the right location for the second hole to go in. Now I'll just repeat that same procedure and continue to move the jig forward. Each time we will use the hole in the jig. I'll get it lined up with the hole down below. I'll put the bench dog in, and that'll give me my exact spacing for the next hole to drill. And the critical part of this jig that makes this all work is if we look over to the left side of the jig, I have it overhanging the table, and then I have a board that is screwed in place to keep this perfectly aligned and square with the edge of the table here. This allows me to push the whole jig forward, basically slide it forward, and keep it square to the edge of the table. So this way I know those holes are going straight forward in a straight direction that's square to the edge. In order to get that bench dog into each subsequent hole, I kind of had to lift the jig up a little bit and fiddle with it to get that bench dog to go in, and then I was able to push the jig back down snug, and it worked out great. When the first row of holes were done, we just moved over to the middle hole on the vise and just began the same procedure all over again, walking forward one hole at a time. I did have to relocate the board that was on the far left side of the jig to be closer to the edge of the table, since my whole jig slid over to the left about 8 inches. And that was basically it. Just repeat the same procedure all the way to the end of this row as well. Once we reached a certain distance, it was a little bit difficult to reach to the end, so my daughter Maya climbed up on top of the table and finished the holes all the way to the end for us. Just a little comment about why I used a router here instead of a drill. If I was to use a hand drill, I would have a hard time ensuring that the hole was exactly perpendicular to the surface of the tabletop. Whereas with the router, that's very easy. We would be unable to get a drill press over this area, and so this is really kind of the best option. So that wraps up the bench dogs, and if you recall, this is the area of the tabletop which we filled with solid blocking before we flipped the tabletop over. So all of the bench dogs are going down into solid blocking, and that makes them just a little bit stronger than going through the plywood all by itself. Now I did not drill these all the way through because I plan on using the shorter bench dogs like what Rockler has here. If I ever wanted to switch and use something else that needs to go all the way through, I could follow up with a handheld drill at this point because I have a pretty square hole started and I could drill them all the way through. Once that was done, we took a few minutes to sand the corners, the edges, just to soften them up a little bit because they were a little bit sharp. So I'm just going to show very briefly what I did for the electrical boxes. My daughter Sai is putting a hole in a predetermined location where I know that coil of wire is, and right in this corner is where I'm going to mount the electrical box. I'm not going to show you how I did it because I don't know who out there is an electrician and who isn't, and I don't want anybody to wire something that might end up being dangerous for them. But essentially we pulled the wire through like this at each of the four corners. And I also took an extension cord, which I cut the end off of, and I drilled a hole into the table to send this extension cord in behind this vertical structural piece. You see the hole below there was a mistake. I hit a bolt, so I had to drill a hole above it. And so I sent that up to the electrical box as well, and that's essentially how I ran the wiring for those. If you need more specifics, you can always email me. I can give you a few more details, but I didn't really want to put wiring out there for the general public. And finally, we are on to the finish. We decided to use lacquer to begin with, and I think we ended up putting about 6 coats of lacquer on the top. We brushed all of the lacquer on as opposed to spraying it. Tried to put fairly thin coats, and then we let it dry and sanded it lightly between coats with 400 grit. And after I think 6 or 7 coats, it started looking really, really good. And you can see the grain really pops here when you put the lacquer on, especially this tiger maple figure here. It's very nice. And we essentially coated everything that we could reach. We redid the fronts of the drawers, the solid wood drawer fronts. We did the drawer boxes themselves, the shelf, everything that we could reach with the brushes. One thing that you should remember about lacquer if you decide to use it, whether you use the spray-on or the brush-on, the solvent that dissolves lacquer is very harsh, very aggressive, and can actually cause neurological damage if you inhale the fumes. So you definitely need to wear a respirator when dealing with lacquer. There are many different types of finishes out there, and some are worse than others. And I really like lacquer because it's inexpensive and it's beautiful. But just make sure that you wear a respirator when using it. A dust mask, of course, doesn't work. You need a chemical respirator, and they're not that expensive. I think you can get a real high quality one for about $30. So after we put the last coat of lacquer, we put more lacquer on the top, maybe I think 8 coats we ended up with on the top and the outside area of the torsion box top. But after our very last coat of lacquer, we sanded the whole thing down with 1500 grit, wet or dry, sandpaper, and then we waxed it. So the reason I wanted all this extra protection on the top is because, of course, I'll be gluing on this surface. And if I spill glue on it, if it's waxed, the glue will just pop off. It won't stick to the surface. This is what I've always done for my assembly tables. And if I have even if I have a really nice assembly table, it seems to last a long time without trouble because I always keep it waxed. So wax is something that we would typically apply once a month or so. If we end up scraping off a lot of glue, or I end up sanding the surface for some reason on accident while I'm operating my sander, then it's really no big deal. I just maintain it with wax pretty regularly, and it seems to work really well. One final note about why I like lacquer is that lacquer is a very easy finish to repair, probably the easiest of all of the top coats. If you were to use polyurethane, for example, and you were to damage the surface and you needed to put another layer or coat of polyurethane on in the future, you would find that polyurethane does not bond very well to old polyurethane that has already been cured. And in order to achieve any sort of long-term success with putting new polyurethane on, you would need quite a bit of prep work in order to make that happen. Lacquer, however, is different. When you apply new lacquer down on top of old lacquer, the solvent that's in the new lacquer will actually dissolve the old lacquer, and the two will fuse together and just become one finish. That's important, especially in shop furniture, and especially on something like an assembly table or a work table, because I might be sanding on it, scraping on it, gouging on it. I don't know what all is going to happen, and the surface inevitably will get damaged over time. But it really will never be a problem because I can always just add a new layer of lacquer. It's going to dissolve the old layer a little bit, and I'll end up with a nice new finish each time. Although I suppose the truth is the nicer the shop furniture that I build, the more careful I tend to be with it, so maybe I won't damage this one at all. Once we get a good layer of wax over the surface, we will take a clean, dry cloth, and after the wax dries, we will buff it out to a good finish. And I'll probably put a second coat on just for good measure. And that is going to wrap up this project completely. If you made it all the way to the finish with me here, thank you very much for watching.